So array methods, some of which like index of and dot reverse. Um, okay, so like strings and like really most computer programming languages, right? They want to make your life easier whenever possible, and so they do build in a bunch of functions for you that you can use. We've seen a few. We've seen a few already, including reverse, index of, dot pop was another one that came up. But there are a ton of array methods that we can do that are common ways that people want to modify or make use of arrays. So here's a list of some of them. Uh, don't feel the need to memorize all of them. And in fact, that link at the very bottom, it will give you a list of a lot of array methods. There's probably realistically only like 4 or 5 that you really kind of need to know on an ongoing basis. And if you ever are doing something and you just feel like, hey, I wonder if someone does this, like Google it. Like you actually never know. More often than not, you'll probably find someone that has the same problem and they just build something for it. So that's another really good part of programming is that you've had a lot of developers who come before you who have a lot of experience but are also very lazy and they're just like, I only want to do this once and never do it again. So we can reap the rewards of their hard work. Okay, so for every array methods, and we saw the danger of this when we used pop earlier, right? Is is it modifying the underlying array? And the reason why that is super important, and I keep hinting at this pass by reference versus pass by value lecture that we're going to have, right? But if you remember this morning, I said that when we were assigning bond and an agent, one of them was called like body double, right? We're like, oh, it's fine. It gives you a copy of the string, so no one can ever edit it ever again, right? With arrays, that's actually not how it happens. With arrays, because it's not a primitive type, everyone's actually sharing that same exact array. So if you change the array in one place, it changes it for someone else there, right? So we saw it earlier when we were doing pop on the array. It felt really good to pop off all the elements on the array in our initial function, but what we didn't really necessarily realize that, wow, like downstream, if someone else were to use that same array, they're going to get nothing. It was going to be a completely blank array. And so the first question is always just, what is this doing? And more importantly, is it changing the original underlying array? And the second one is, what does this method actually return, right? There's a lot of assumptions that we sometimes make about, well, if I was to just, if I wanted to reverse an array, is that changing the original array, or is that giving me back a brand new array? Because if it's giving me back a brand new array, I would need to capture a variable, right? If it's changing the underlying array, then I don't need to. So like those questions are like, they might seem kind of trivial, but like once you start doing it, you also quickly realize that like your code just will not work unless you do it in the right way. So the first class of methods are called mutative arrays. So as the name indicates, they actually fundamentally modify the underlying array, right? So even something as simple as dot push, that counts, right? Because when we dot push something, we're now taking the original array and we're making it one element longer. Okay, so these are definitely all things that do matter. And because they are changing things, they will actually also implicitly return a value, right? So every time you guys were doing dot push, it was returning to you, in this case, the length of the new array. But we didn't care about it. We weren't doing anything with it, so we just kind of ignored it, right? So it was a silent return. But it doesn't mean that nothing was happening behind the scenes, right? It was still returning, right? And so this is really, really useful when you want to do a dot pop, right? Because dot pop, if you want to remove the last element in the array, usually it means that you also want to know what is being removed. And so these are kind of handy ways for you to kind of get references. Sorry, these are handy ways for you to get references to what exactly is being changed. All of these are things that you're not expected to memorize, but you are expected to be able to do a quick Google search, read it, and really quickly kind of get a sense of, oh, this is doing this and this. So if I use it, I should expect it to do this and this. In fact, when you're doing some of the problems, like it's almost like I would be surprised if you didn't have like the documentation open on one of your partner's computers. Like these are things that once again, you don't have to memorize, but they're definitely things that you need to understand. So the index of the little function that we were just working on earlier, right? This one we kind of covered a little bit, but the kind of tricky one for this one is just that it returns something kind of unexpected, right? Which is that it returns a -1. Once we talk about it, it's like, okay, cool, that makes sense. But if you never saw it before, you may be wondering why do I have an index of the -1? That doesn't make sense. So that's why we kind of fleshed it out on its own here. The other thing about index of that's also very important to note is that it only returns the first instance it finds. So if you care about the second or the third or the x instance, then you probably want to use another potential method for it. Okay. One thing that you'll quickly get a sense of is this idea that like a lot of times functions do a lot more. A lot of times methods do a lot more than you think they do, right? So historically, but over the past 2 days, whenever we've used index of, we've given it one element and we say, great, search for it, right? And we've always kind of assumed that's how index of works. But index of can actually also take multiple optional arguments too. And what those optional arguments does is it actually gives it an extra layer of functionality, right? So one example we have is this, right? So if you give index of just a word, it'll say, great, let me search for that word, or search for that, for that element. If you give it a word and the second argument is a number, then you're actually telling also the array, say, hey, like look for that word, but only find instances after this index. So if you say, I only care about, if there's any instance of for example, if I was to iterate through someone's attendance list, right, I only care about whether or not they were absent in the past week. Like that's an instance in which like I would definitely want the second element there, because then that gives me a context for understanding where specifically in the list I'm looking for. Okay. And to go back to the previous slide, a lot of these also have optional second or third arguments too. So you might not need to know them for today or even for this workshop, but just keep in mind that like a lot of these functions do really cool things. And so what you necessarily see is not all it's not just all the value that it represents. Okay, next one up is slice. Slice is a fairly tricky one, and the reason why it's tricky is because the next one we're talking about is also called splice. They do actually incredibly different things, which is why it can be a bit dangerous. But slice is what you want to do when you want to copy a portion of the array, right? So slice is really safe. Why? Because of that second bullet. We're not editing the original. Array, which means that we can slice an array all we want, and nothing's going to change in the original array. However, what that also means is if we ever do a focus.slice or a focus.slice, we need to be capturing something, right? The original array is not being changed, so that just means we're generating a new thing that we need to store in a variable somewhere. The last thing is something that we also saw yesterday in the nickname generator problem, right? Do we want to give someone's first 4 letters, or someone's first 4 letters, or someone's first 3 letters, right? And so in slice, you're giving it 2 numbers, but as we saw yesterday, the first number is inclusive, so we do store that index. The second number is exclusive, which means we stop when we get to that index, and whatever is that index is not being captured as part of our copy. So I mean, we saw yesterday kind of how it works, but that's just like the thing to keep in mind is that the 2 numbers are treated differently. And I actually think slice also has maybe some additional parameters too that does other cool things, but for now at least this is kind of what the basics of slice. Splice, on the other hand, is different and dangerous because it does modify the original array, right? We can use splice to either add or remove elements to an array, and the arguments that you see are there. It tells you where to start, how many things you want to delete, or what things you want to add, right? But if you look at this .slice, what is it? All right. So in this case, we have folks, there's John, Sarah, and Ed, right? When we do a .splice and we say person equals to, if this was sliced, then we would think, oh, this is giving me the entire new array back. But in actuality, what splice really does is it actually tells you only the elements that were changed. So in this case, we remove Sarah. And so what is being stored in person is actually Sarah, whereas the original folks that got spliced is also changed. Once you work with it a little bit, you'll get a better sense of kind of how these arrays work. But just know that splice is usually the one that I take a lot more care with, because once again, you're modifying the underlying array, and it's sometimes hard to undo that once you splice something. And then lastly, and that link will show you, the Mozilla Developer Network is probably by far the most comprehensive set of documentation on the internet about JavaScript, specs and functions and how they work. Reading documentation is going to be a huge part of your life as a developer. Like, there's no shame in Googling for answers, but like even more so in engineering because there's just way too much and no one is expected to know all of it. But especially kind of where you're at, any problem, any technical issue that you have, I guarantee you someone else has seen it before and they figured out the solution to it. So save yourself some time by just reading some of the docs or reading the manual. It's probably the best way to learn most concepts. Okay, and then a bit of a non-sequitur here. We're going to talk a little bit about debugging too. And some of these you've seen me do whenever we go through the problems together as a class. And I think this pie chart I think does about right. Like a very small part of your life as a developer will be you like writing new code. More often than not, the vast majority of your time will be spent either reading other people's code, trying to understand it, doing research, or debugging your code, right? Like code very, very, very rarely ever runs on the first try. In fact, to the point where if someone writes a code, like any developer that I know at least, if we write code and it works the first time, we assume we did something really wrong. Like that's just like the default assumption because you're like, there's no way this is going to work right the first time. Console logs. A few tips. Or actually, I guess only one tip here, which is that I always like to put some kind of description in the same console log statement, right? Like this up here, works in the short term if you just want to have something you just want to log out really quickly. You're checking it, you're mentally very aware of it. But in cases where you're trying to, for example, track how a variable changes over 4 or 5 different steps, I always like to add a comment before. It's before initialization, after splice, before slice, after whatever, right? And so when I read the comments, especially in cases where you're looping over something, and there's like a huge row of outputs right away, having something like this really makes it clear kind of where you are in the code, and it will make your console logs a lot more effective for you too. Secondly, console logs is meant for human consumption, but which also means that there's sometimes like slight deviations from what a console log shows versus the way a computer necessarily treats it. So all of that is to say that don't necessarily use a console log and think, oh great, this looks right and it must be what the computer is ingesting too. Like there's often smaller deviations. Rather, console logs should just be one step of the triage or the resolution process. It shouldn't be your entire solution. And then lastly is this like you don't perform operations in your console logs statements. That really depends, but you should never do anything mutative in the console log, which means you should never be changing anything underlying in the console log. However, if you just want to know what this number plus this number is, I've done it before too. It's fine, but in general, probably not the best practice. And so here's an example like we're logging 8 nested arrays or whatever, and the output is actually just something that tells you, hey, there's a nested array. And so what the console log shows doesn't necessarily reflect what the underlying asset is. And then return versus console log. I think I've kind of beaten this horse pretty dead at this point, but like console logs purely for humans. Return is what you want to use when you actually want to use the values for anything programming related. Oh yeah, and then logging at strategic points, right? This is just kind of what I've been harping on about. Like whenever I walk around and look at your code, right, I always say, great, what is this value at this point? And you say, I think it's this. I'm like, prove it, right? Drop console logs, like dropping, like even in the last problem, that we did, right? We were trying to iterate over something many, many times. Well, one really, really easy way to figure out whether or not you're running that code the number of times that you think you are, is to drop a console log every time it loops, right? So therefore, if you see 6 console log messages, then you know it ran 6 times. If you only see 1, then you know it only ran 1 time, right? Like those are all things that you just make your life a lot easier, and use your best judgment. But there are some cases where it just looks like a really clear candidate where something is happening, and you just want to do a quick before and after comparison. Okay, the last part is error messages. JavaScript has a bunch of error messages. Some of them are helpful, some of them aren't. I think we've seen a few of these already, right? So type error, when we try to call a function that's undefined and we try to execute it, we get a type error saying, hey, this is not a function, right? That's an example of a type error where basically something can't do what we're asking it to do. Reference error is the other easy one. It just means we want to do something with the variable that doesn't quite exist. Like the example here, usually it's a typo, right? Usually it's like we misspell something, but that's kind of the root of that error. Syntax error is a little bit more often like a fairly syntax error is kind of a double-edged sword in that like sometimes it's not very clear because you might have like a misindentation, in which case properly spacing your code makes it a lot easier to figure out. But also sometimes you may be missing like a reserved word, and it will just say it will give you a syntax error, but it's not quite clear what it is, right? So like if you're missing, for example, the closing parentheses in your for loop, like in the parentheses, not in we do the condition, it might give you an error saying, oh, I expected something else, and it might look a lot worse than it really is. But once again, console logs and these error messages are kind of tools in your toolbox, if you will. But none of these things are guaranteed to be like a one size fits all kind of resolution. Okay, I think that's it. Yeah, so that was it. Kind of talking about array methods and a lot of those, and then also talking a little bit about debugging. So any questions there? Everyone's good? All right. So the problems for this workshop, there are quite a few, and this will take us through the rest of the class. So the first one is called debug hunt. You copy and paste that code and try to run it, you'll get a bunch of errors. Figure out what's wrong, right? Like don't worry about necessarily about what the code's doing. Just make sure you get rid of all the errors. It should be pretty self-explanatory. The next problem is called even and odd, and that's just where I give you an array, and you should give me back two arrays, or yeah, you give me back two nested arrays essentially, right? Like one array with two arrays inside of it, one of all the original arrays even numbers, and one with the original arrays odd numbers. Okay. The next four problems, my unshift, my join, my last index of, and my slice. Once again, just like the reverse problem was last time, like yes, those all exist in JavaScript array class, right? Like, but don't use them if you could. Like right now, what we're trying to do is really get you to understand the logic behind why they're made and how they're made and how they're implemented. So please like try to write your own version of it. If you really get stuck and you want to Google, like how the official one looks or how the docs talks about how it behaves, feel free to. But at the end of the day, like we're aware that these things already exist. We're just having you rebuild them to make sure that you really understand the logic. And then the last one is a rotate array. And this one is actually a bit trickier, but essentially what it does is having you think about, hey, if we have an array that's has a certain order, how do we shift around that order, or how do we move things around? So in this case, you are also moving the underlying array. So you probably want to make some decisions about, do you want to give back a new array, or do you want this to maybe shift around the original array instead? And I guess in this case, the problem is asking you to give back a new array, so you can probably start there. Okay, any questions on these problems? I know I went through them pretty fast, but the prompts and like hopefully you get a sense of kind of what we want you to get out of this experience. Okay, sounds good. Well, so the problems are unlocked, and then I'll select out partners now.